This one's a bit of revision. It does things we've done before, but ties it all together. So let's have a look at it. So we're trying to find a unit vector perpendicular to the plane. So that perpendicular to the plane is what we've been talking about as being normal. And it contains two vectors. So we'll call this one A and this one B. So effectively, A is going to be the vector 2 minus 6 minus 3, and B is going to be the vector 4, 3, negative 1. Excuse me. And we want to find something which is normal to both of these vectors, so we're going to do the cross product. So we go A cross B is I, J, K, 2 minus 6 minus 3, 4, 3, negative 1. So for the I one, we're going to get 6, take away negative 9 is 15. And then when we do minus for the J one, it's always minus, so we've got negative 2, take away negative 12, which is the same as adding 12, which comes to 10, and it's minus, so 10J. And then with the K one, we're going to have 6, take away negative 24, which is adding 24, which is 30, so plus 30K. So this vector is normal to the plane. And personally, I would just carry on, and because they will obviously divide by 5, I would go a normal vector is 3i minus 2j plus 10k. It's the same direction, it's just scaled back by a factor of 5, so my normal vector here is the same as that one there, and it just gives me a just makes it easier to work with numbers when it comes to trying to figure out what the size of the thing is. So I've now got a vector, normal or perpendicular to the plane, and I want to make it a unit vector. And remembering the unit vector, you have to find the size of it. So the size of this thing is just going to be equal to the square root of 3 squared plus negative 2 squared plus 6 squared, isn't it? I've got lost my marbles here. 30 divided by 5 is only 6. So it's a 6 squared. Oh man, losing it all over the place here. Okay, right here, now we're into it. It's at 3261 again, isn't it? So we've seen that before. So 9 and 4 is 13 and 36 is 49. Square root of 49 is 7. So my unit vector is equal to 1/7 of the vector I was working with, 3i minus 2j plus 6k. Okay, which I could also write as 3/7 of I minus 2/7 of j plus 6/7 of k. Either of those two is fine. Okay, so the key here is that to find a vector normal to the plane, we've done the cross product of two vectors which are in the plane. So we know that the thing here is at right angles to each of the two vectors we started with, therefore it must be at right angles to the plane, so it's normal to the plane, and then we've just made it a unit vector.